Hello and welcome back to another speedrun. Today we're going to be, well, not today, this is the sixth speedrun of today, but we're going to be covering absolute value functions. And yeah, let's jump right in. So if you're not sure what absolute value is, the absolute value of a number is equal to whatever the positive value of the number is. So it's equal to the number of itself if the number is greater or equal to 0, and it's equal to the negative of the number if a is less than 0. So just think about it as okay, so the absolute value of 1 is 1, the absolute value of negative 1 is 1, the absolute value of negative 42 is 42, and the absolute value of 0 is 0. It's like converting negative numbers to positive numbers, but leaving positive numbers alone. Okay, so the absolute value has a few interesting properties, which I will quickly go through. So first of all, absolute value of a number is always greater or equal to 0. The negative absolute value of a negative number is equal to the absolute of the number. If the absolute value of a number is 0, then a is equal to 0. If the absolute value of the difference between numbers is equal to 0, then the numbers are equal. Quite a few more. So if you multiply the absolute values of two numbers, it's also equal to the absolute value of the numbers multiplied together. And it's the same thing for division. So if you divide the absolute values of two numbers, it's equal to the absolute value of the quotient of the two numbers, as long as, of course, b is not equal to 0. If you add two numbers, the absolute value of the addition of two numbers is always less than or equal to the absolute value, the sum of the absolute values of the individual numbers. And the absolute value of the difference between two numbers is always greater or equal to the difference between the absolute values of the numbers. And finally, if the absolute value of a number is less than or equal to the absolute value of another number, then the first number is in between the negative of the second number and the positive value of the second number. And if it's greater than, if it's greater, let me just cover this quick case. If it's greater than this, then it means that the number is either less than the negative value of the number, or it's more than the positive value of the number. That was a very long list of things, but you should get what an absolute value is by now. So let's just jump into some questions, and this is another short section. It's just asking about the domain and range of a lot of absolute value questions. Actually, a heck ton of absolute value questions. So we need to determine the domain, and I'm not typing. We need to determine, I'll just say, we need to determine the domain and range of these functions and sketch their graphs. So the first function is y is equal to the negative absolute value of x plus 3. Quite a tricky function to start. So we got to think to ourselves, what is the domain of this function? The domain is pretty much actually if x is part of a real number. But what is the range? And the range, well, we know that the greatest value negative square root x a negative absolute square root value of x can have, this will always be less than or equal to 0. So this y will be at its greatest when this is 0. So y will simply be less than or equal to 3. That's the range, that's the domain. And if we sketch this, well, let's think. Y equals a negative absolute value of x plus 3. Well, when x is 0, y is at its peak at 0, 3. And it would just go downhill from there. It would look sort of like this. Okay, now on to the next one. We have y is equal to x minus 3 minus 4. Again, the domain should be x as part of all real numbers, but the more interesting question is, what is y? So this absolute value function will always be greater or equal to 0. So the least value y can have would be, when this is 0, in this case, it would be 0 minus 4 is negative 4. So y is always greater or equal to negative 4. So that would be the answer for this. For what this function looks like, let's think. We have our minimum when x equals 3, and it is at negative 4. So it should be somewhere here, and otherwise it is going up. So our function should look something like this over here. Actually, technically I've drawn this horizontal axis wrong. It should cross the vertical axis before the horizontal, but it should look something like that. Okay, on to the next one. So we have y is equal to 1/2 times x plus 2 minus 1. Okay, so again, x part of all real numbers, but what is y? So the least value that this part can have is 0. Or, yeah, because when x equals negative 2, absolute value of negative 2 plus 2 is 0. So 1/2 times 0 is still 0. So the least value y can have is negative 1. So y will always be greater or equal to negative 1. The hardest part is, what would this graph look like? So we know the minimum value of x is reached when x is equal to negative 2, and it's at y is equal to negative 1. And it would have a much higher, like steeper gradient this time. Oh, sorry, not steeper. Actually, it would be a much flatter gradient. Actually, I think it would pass through the origin, I believe. Let me just check that. Yes, it does indeed pass through the origin, and it would be a much flatter gradient since we're multiplying this all by 1/2. So it would take a greater x to reach the same value of y. Okay, let's move on to the next one. We have y is equal to negative 3 times 1 minus x plus 2. So domain, it's still x is part of the real number set, but what is the range? And, well, the greatest value, negative 3 times absolute value of 1 minus x is 3. So this will always be less than or equal to, sorry, is 0. So it will always be less than or equal to 0. So in the case that this is 0, the y value will be 2, so y will always be less than or equal to 2. Finally, our graph over here, we have the minimum at x equals 1, and that's around there, and it's at 2, and it's going downwards at a very steep slope. So it would actually look something like that. Okay. Finally, let's move on to the last question. Y is equal to 2x squared plus x minus 3. Ooh. Okay. So, what is the domain? The domain is still x is part of the real number set, but what is the range? The range is kind of cheeky. It's just y is greater or equal to 0, since the least value this can have, regardless, is just 0. And it does have roots for a reason that you might learn. Actually, no, just don't, never mind. The least value this can have is 0. And I guess the only thing we would want to check is that if this function can actually reach 0, and if it does reach 0, it means it has a root. So we do that by looking at the quadratic equation, which of course you know is negative b plus or minus the square root of b squared minus 4ac over 2a, and we need to look at this thing in particular, which is the determinant. or actually, I'm not too sure what exactly it's called, but you use this to find whether the function actually touches 0 or not. And the thing is, b squared, for this to have a value or a root value, a real number root value, b squared minus 4ac must be greater or equal to 0. If it equals 0, it means there's one root. And if it's greater than 0, that means there are two roots. So let's just quickly check that. B squared is 1 minus 4 times 2 times negative 3 is definitely greater than 0. It's 1 minus 1 plus 24 is actually 25. So yeah. And so what would this graph look like, though? Well, what I do to imagine what this graph would look like is you first want to draw out the actual graph of this quadratic. 2x squared plus x minus 3. It would look something like x is 0, 3. It would look something like this, I believe. Yeah. So, oh, actually, am I wrong? 2x. Oh, that's minus 3. Sorry, I thought it was a plus. I was like, what's going on? Anyways, the graph would look something like this normally, right? You have your y-intercept at negative 3, and it's a positive concave up graph. But for the absolute value function, what you do is that you just chop off, imagine getting a scissor and chopping off everything below the x-axis and then just flipping it vertically, like that. And erasing it, of course. At the bottom, oh, I've just erased everything. Anyways, erasing it at the bottom of the x-axis. So your graph would actually look something like this, and that is correct. So that was all for this absolute value speedrun. I think the next exercise continues onto it, and I hope to see you in the next speedrun. Ta-ta!